Okay, new topic, adding, subtracting, and multiplying radical expressions. Now here's the deal. When you add and subtract, it's pretty picky. You can only add and subtract things that are exactly the same, right? I can only add an x with an x, a y with a y, all that great stuff, right? Well, when it comes to radicals, they have to be exactly the same. You kind of have to treat them like a variable. So if I want to look at problem number 1 here, that's my example for us to look at. I notice I have 2 times the square root of 3, and they're asking me to add 4 times the square root of 3 to it. Now here's the deal. I need you to look at the radicals like they are variables. And I need you to ask yourself if those variables are exactly the same. They are. They're both square roots and there's a 3 under both of them. So they are exactly the same. So that's almost like saying 2z plus 4z, right? So I can add those, can't I? What would you get? You would get 6z, correct? So here I could add the 2 and the 4, couldn't I? What would I get? 6 what? What's my variable? Yeah, square root of 3. 6 square root of 3. Just because that square root of 3 is a number doesn't mean that changes. It remains 6 square root of 3. Just like here when you added the z's, the z didn't change, did it? No, it's like you're counting them up. I have 1, 2, 3, 4, 5, 6 z's. Same thing, 1, 2, 3, 4, 5, 6 square root of 3. So to speak. With me? That's kind of a way to look at it to help you out. Good? Okay, problem number 2. Now they're asking me to subtract. And the question is, am I allowed to subtract these? Good, why? Yeah, these square roots are like my variables and they're exactly the same, which means I can subtract what numbers? The 4 minus the 7. What would you get? Negative 3. Negative 3 what? Times the square root of 7. Excellent. So far so good? Okay, number 3. Again, they're asking me to subtract. Can I subtract these? Good, you cannot. Why? Yeah, the root may be the same. They're both square roots, but the numbers underneath are different. You can't add these if they're different, or subtract them for that matter. So here's the deal. We're going to use a technique that we used in a previous lecture, and we're going to break down this 8. We're going to simplify this square root. And I'm going to try to do the same thing with the 32. Because if I can simplify these, then maybe I'll end up with a problem that I can subtract. With me? Okay, so 8 breaks down, right? Yep, 2 times 4, 2 times 2. So I end up with a pair of 2's, don't I? So on this, the 2 comes out from this pair, and this guy, being all by himself, stays inside, right? And if you need a refresher on how to do this stuff, go back and look at that video. Okay, 32. Break it down. Yeah, 2 times 16, 2 times 8, 2 times 4, 2 times 2. What do we have? We end up with 5 2's, don't we? But we are looking for pairs because we are looking for a square root, which means I take out 1 2 from here and another 2 from here, and this little guy gets to stay home, so to speak, right? Right. Okay, so I have 2 times the square root of 2 minus, good, 4 square root of 2. And the question is, can I subtract those? Yes, I can, because the square root of 2's are exactly the same, which means I can do 2 minus 4. So what is 2 minus 4? Yeah, that's a negative 2 square root of 2. Cool? Awesome. Okay. I'm going to change this one to an addition problem. Why? Because I want an addition problem. All right, so the question is, can I add these two together? Nope. Why not? Because they're not the same, right? They're not the same. So, yeah, we're going to have to break down this 27 if possible, and the same with the 75, right? Okay, so get over there, go do your work. I'm going to break down the 27. Pause the video, by the way. Let's see if we get the same thing when we do this. I got 3 square root of 3 for that square root of 27. Did you get the same? Good, because I had a pair of 3's and this little extra guy left over, didn't I? Okay, 75. Pause the video. Don't look at my work. Okay, so on this one, I can take out a 5 from this pair, and this little old 3 is by himself, so he gets to stay underneath. So I got 5 square root of 3. Did you? Awesome. So can I add these? Yeah, because they're both the square root of 3, so I can add them. Yay! What do we get? 8 square root of 3. So far, so good? Cool. All right, so let's look at problem number 5. They're asking me to add, and the question is, am I able to add these? Oh yeah, certainly not, because these radicals are not exactly the same, are they? So, if possible, we have to try to simplify those guys first, right? So let's look at this first one. Underneath is a 45 times an x to the third. So because it's multiplication under there, do I have to keep them together or can I look at them separate? I can look at them separate. Good, because it's multiplication, so I can kind of split things apart. So first thing I'm going to do, first we're going to look at the 45, and we're going to break it down. That's 5 times 9, and then 3 times 3, right? So it looks like I can pull out a 3, can't I? And that little 5 stays underneath, right? But there's an x to the third as well. And if we rewrite that with a rational exponent, the power is 3 on the x, and the root is a 2, which means that 3 over 2 means 1.5. 1 x has come out, and 1 stays inside, right? Just like we spoke about in a previous lecture. So, here's the 3 on the outside. We decided that we could take out another 3 from here, right? And that 5 would stay under the square root. Agreed? Now on our x's, we decided we could take 1 out, but then there was 1 left underneath. Agreed? So when I simplify this, on the outside is actually a 9x times the square root of 5x. Right? Okay. Now, this latter part, you know, I'm noticing that the square root has a 5x under it also. And, you know, I really can't break down the 5 or the x underneath it anyway. So I actually only had to simplify the first radical, and now these look exactly the same. So can I add? Yeah, I can. So what would I get when I add these? Yes, a 9x plus a 1x is a, good, a 10x times the square root of 5x. Cool? Okay, so clearly you have to know how to break these radicals down, because that's going to help us with all of these problems. So if you need to go back and look at that previous lecture video, then go back and look at that previous lecture video. But that's going to be key to us being able to add and subtract these things. Good? Okay, let's look at problem number 6. Now I see I'm dealing with a cubed root, aren't I? Okay, so, and I'm subtracting, but they're not the same, are they? All right, so let's see. On the first cubed root, the 3 and the a to the 4th is multiplied in between, and gratefully, I can look at them separately. So, The 2's on the outside. Can I take the cubed root of 3? No, so that's going to stay on the inside. Now this a to the 4th. So I'm going to rewrite it. That's a, what's my rational exponent? Good, power of 4, root of 3, so 4/3. So when I look at 4/3, that's 1 and 1/3, which means I can take out one of the a's, right? And that's taking out one of the a's, and this a is left underneath, isn't it? Got it. Minus, so I have this 3a on the outside, don't I? So I've got a cubed root of 81 times a. So since that's multiplication, do I have to keep them together, or can I look at them separate? Good, look at them separate. So I got to deal with the cubed root of 81, don't I? All right, time to break it down, or do you have it broken down already? You know, you pause the video, you go break it down, and when you've broken it down, start the video again. I'll be back with you. Okay, good. You broke it down? So here we go. From taking the cubed root of 81, I was able to pull out a 3, and I noticed a 3 got left underneath because 81 broke down to 4 3's. So 3 of them gave me this guy on the outside, and that 1 gave me the a on the inside, or the 3 on the inside. And this little a, there's not much I can do with him, so he stays inside also. So here's what I'm noticing my next line to look like. I have 2a times the cubed root of 3a minus, what do we get here? 9a times the cubed root of 3a. So can I subtract them? Yeah, I can. That's awesome. So I get what? Good, negative 7a times the cubed root of 3a. Cool? Yeah. I would pause this part of the video and go back and look at these two problems again if you need to, because there's a lot going on in these two problems, but they're not bad. They're banking on you knowing how to break these guys down, the numbers as well as dealing with the variables, right? Okay, so stay tuned. We got some multiple. Okay, let's look at problem number 7. What is it asking us to do? It is asking us to multiply. That is definitely a distribution problem, right? So we're going to distribute like we're used to distributing. So the only difference here is we're distributing radicals. Now, the one thing you have to make sure of is that the roots are the same. Just the root, not the number underneath, but the root. Outside is a square root. Underneath is another square root and another square root. So I can multiply this square root of 7 to both of these guys on the inside because they are all square roots. So we have no problem there. Got it? Okay, so we are going to take what first? We are going to take the square root of 7 and we are going to multiply it to the square root of 5. Good. And then we're going to add to it the square root of 7 multiplied by the square root of 3. Excellent. That's our distribution, right? And so yes, I am writing like these little steps out because I know some of you are going to want to see them to help yourself out, and you write them on your papers. So, what's the square root of 7 times the square root of 5? Good, the square root of 35 plus, what's square root of 7 times square root of 3? Good, square root of 21. Now, can I add them? Well, the roots are the same. They're both square roots, but the numbers underneath are not the same. So now that question is, can I break down the 35 and pull out a number? No, because that's just 5 times 7. Nothing to do there. What about the 21? Nope, can't do anything there either. So is this my final answer? Yeah, this is my final answer. So be it. If they don't want to add, they don't have to add. Cool? All right, let's look at problem number 8. Now, do you notice problem number 8 has that square on the outside, which means I actually have how many of these parentheses? 2 of them. Okay, so I don't know about you, but me being a visual person, I'm going to want to write them both out. So I've got the square root of 5 minus the square root of 2 in parentheses multiplied by itself. Got it? So this is definitely a distribution problem, right? And I know some of you learned FOIL, but this is how I take this distribution, okay? This is how I teach distribution. By the way, all of them are square roots, so I know they can all multiply together. So first things first, this square root of 5 will get multiplied to that parenthesis, won't it? And then this minus square root of 2 is going to get multiplied to that parenthesis also, isn't it? Agreed? Yeah. When you distribute, that's how you distribute. Now, if you're foiling, you're going to end up in the same place we are, so just watch and hang in there. All right, so square root of 5 times square root of 5. Good. Square root of 25. Square root of 5 times a negative square root of 2. Good. A negative square root of 10. This one now. Negative square root of 2 times square root of 5. Negative square root of 10. And then a negative square root of 2 times a negative square root of 2. A positive square root of 4. So, let's see what we can simplify. Square root of 25, what is that? Yeah, that's just 5, so yay for that. So there is 5. Now, I have a minus square root of 10 and another minus square root of 10. Help me out here a second. What are the numbers in front of those guys? Yeah, that's a 1 and that's a 1, which means negative 1 square root of 10 minus 1 square root of 10. Yeah, I heard you. Negative 2 square root of 10. Good, because a negative 1 minus 1, right? And, oh, what's the square root of 4? 2. Love it. Anything else I can do? Yeah, I can add that 5 and that plus 2. That'll give me a 7, won't it? Anything else? Nope, that's it. Cool? Okay, you know how to distribute. The deal here is you've got to be careful with these radicals. So stay tuned, I got 2 more. Okay, I'm back. Problem number 9. Definitely a distribution problem, so I'm going to tackle number 9 like I tackled number 8. You guys might do your foiling and that's fine, but I'm just going to take it as a straight distribution problem, which means I'm going to take this 8 square root of y and I am going to distribute it to that parenthesis. And then I'm going to take this plus z and distribute it to this parenthesis as well. All right, so let's see what it looks like. And I can multiply these all, right, because they're square roots, so the square roots can multiply just fine. So I have 8 square root of y times 4 square root of y. Good, that's 32 square root of y squared. And 8 square root of y times a negative 1. Yeah, that's just going to make it a negative 8 square root of y. Cool? Okay. Now the plus z times the 4 square root of y. Yeah, that's going to be plus 4z square root of y. And then plus z minus 1 is minus, plus z times a negative 1 is a minus z. Got it. Good? Okay, let's go back and see if there's anything we can simplify. So 32 and then y squared. Can I take the square root of y squared? Good, what do you get? Yeah, so this would be 32y. Now, I'm noticing these two guys both have a square root of y in them, don't they? Okay, so I'm going to hang on to that for just a second, right? Because the numbers out front are different. So, depending upon the authors of your book, some of them may just leave it this way because even though these are both square root of y's, I can't add the -8 and the 4z. So some will just like, this is it, you can't do anything more. Others of them will write it a little bit differently, so watch. So we have 32y minus z. Now here, since they both have the square root of y, that means technically I could actually add these two guys in the middle. And technically, what I could be adding together is a -8 and a positive 4z. If I could add those together, that's what I would be adding, right? And the square root of y would be on the outside of that. Now that's kind of a funky looking answer. If I was to bet, I would say they would probably leave it this way. Cool? But just to give you a little bit of a what if some of the authors might do. Cool. All right, number 10. Ready? Bunch of square roots, which means we can distribute. Yay! So let's look at what we can distribute. So we have the square root of 5x, and that's going to get distributed to this parenthesis, right? Now, another way of writing this as opposed to writing it all on one line, I can write this one, and then I can also do the -3 square root of 2 times the same parenthesis. I could kind of split it up as two different problems if it looks like it's a lot to deal with. All right? So let's look here. We end up with the square root of 25x squared minus 3. And yes, I can multiply those and we get square root of 15x, don't we? Right? Okay. So this one, when we distribute, looks like we get a -3 square root of 10x plus 9 square root of 6. Good. All right. So let's put these together. This was the result of the first distribution. Here's the result of the second one. So we have the square root of 25x squared minus 3 square root of 15x. Agreed? And then the second result was -3 square root of 10 plus 9 square root of 6. All right. Well, that looks lovely. Anything we can simplify? Yeah, here. Because that would give you what? 5x. Good. Can I simplify? No. Oops, I forgot the x on that one. Thanks, guys. I heard you. Because that was a -3 times the square root of 10x. Good. No. Okay, anything I can add together? No. Well, this answer is just as lovely as the last answer, isn't it? So be it. If this is the way it looks, then this is the way it looks. Like I said, sometimes they come out really nice, like problems, what, 7 and 8 did? And sometimes they come out like this answer and this answer, because I bet that would be the answer that they would give you versus this one. Cool? Okay, you have fun adding, subtracting, and multiplying radical expressions, and I'll catch you on the flip side.